Hey guys, we are almost done. This is our last unit. We only have 6 more lessons for the entire school year. Isn't that crazy? So what we're going to be doing today is we're going to be talking about graphing. But we're not actually going to be graphing today. What we're going to be doing instead is we are going to just be talking about the transformations and the x and y intercepts. That way tomorrow when we do graph, we'll have it all in the bag. All right? So everything's the same as what we've done all year long. We have 3 parts to each of our graphing equations. We have an A, an H, and a K. Now, don't get freaked out. It's the same thing that we've done. We just have log or natural log in here, but our transformations are still the same. My A is still going to control my vertical stretch or compress. So my A is going to control vertical stretch compress. It is also going to control if I have a reflection. Okay, so if it is negative, we have a reflection. And whatever our number is, it tells us simply stretch or compress. My H, let's go to our K. So my K is my up and down. So my vertical shift up and down, that's what that tells me. And my H is going to tell me if I have a left or right, but I also want you to know that H is always going to be backwards. It's a liar. It's inside the parentheses. In my equation, it's backwards. Okay, so it's a liar, and it tells me if I go left or right. Okay, now with that in mind, what we can do is we can come down here and we can write some equations. Okay, so on number 1, we have log of x. We have a vertical stretch by a factor of 6. Now, a vertical stretch by a factor of 6, that's my A. So my A is going to be a vertical stretch of 6. My A is 6. So we'll end up plugging that into my equation like normal. All right. Then we're going to shift 5 units down. Now, if I shift 5 units down, that is my K. And 5 units down means it's going to be negative, so it's going to be negative 5. So now I can just write my equation. So here we go. We're going to go, it gives us f of x. It just wants us to rename it. We're just going to relabel it as g of x. So I'm going to go g of x equals, first letter is my a. Do I have an a? Yes, my a is 6. So I'm going to go 6 times log of, I don't have a base for my log, but that's fine. It's just going to be log of x minus 5. Log of x. I don't have an h to go in the parentheses, so then we're just going to have a minus 5 there on the end. Let's take a look at number 2. Number 2, we have log base 2 of x. First off, seeing that base right there, that's not going to really affect anything. It's just log base 2. My transformations are still going to be the same. It might affect where my graph goes on the actual graph, but it's not going to affect how my graph shifts up and down, left and right, so that doesn't matter. Okay, so reflection vertically. Whenever you see reflection vertically, that tells me that we have a negative out in front. We have a negative A. And a translation 9 units to the right. So 9 units right, that means my H is 9. You might be thinking, Mr. Martin, I thought you said H is a liar. Shouldn't that be a negative 9 right there? And great job of thinking that. What it means is that we're going to have a minus 9 in my equation. Okay? In your equation, your H is a liar, but everywhere else, it's just the number that it is. Okay, so we're going to have g of x equals my negative a times log base 2. That base 2 came from right there. Log base 2 of x minus my h, so x minus 9. See how it's backwards when I put it into the parentheses. And then it doesn't say that I shift up and down, so we don't have a k, and so that's just my equation for number 2. All right, what about number 3 here? Number 3, we have log of x. We have a translation of 2 units up, so that means my k is 2 and 7 units right. So that means that we're going to have an h of 7. So we can write my equation. We don't have to write a base on this one. It's just log base 10, just standard log. And so we're just going to go g of x equals no a, so we're just going to go log of x minus my h plus my k on the outside, which is 2. All right, last couple here, number 4. We're going to translate this 3 units to the left and 1 unit up, followed by a vertical shrink by a factor of 2. So let's start with the 3 units left. So 3 units left tells me that my K is my H. That tells me that my H is going to be -3. Okay? So we're going to have an H of -3 and 1 unit up. So 1 unit up, that is my K, so K equals 1, followed by a vertical shrink. Now remember, shrink, compress are both in the A section. So A controls shrink or compress. So whatever this is, that's just going to be my A is. So A equals 1/2. So A equals 1/2. So now I have my A, H, and K. We can write my equation. G of x equals my A, which is 1/2, times, look back to where we started. What was my starting equation? Now this one was a natural log. Like I said, though, the base doesn't change, even if my base is an E like it is for natural log. So we're just going to go 1/2 times the natural log of x, and this is going to be the opposite, right? We're going to go x plus 3 for my h, plus 1 there on the end. All right, last one on this page, number 5, it says log base 2 of x. Okay, same thing as the one that we did previously. And then it says we have a vertical asymptote at x equals 3. Well, which one is that going to affect? To understand that, we have to talk a little bit about what my graph looks like for a logarithm. So the graph for a logarithm looks like this. It starts here and just kind of shoots up to the right. This is what a graph of a logarithm looks like. And we're going to shift this around and do a lot of stuff to it, especially tomorrow. But this graph, in particular, it has a vertical asymptote. Because remember when I've said that we can't have a logarithm of a 0 or a negative? Okay, we can't have a logarithm of a 0 or a negative. So that creates this asymptote. It creates a space where my graph cannot touch. So if my vertical asymptote is here, and I move it, it starts at 0, and I move it to the right 3, what I'm really doing is I'm shifting my entire graph to the right 3. So that means that whatever my vertical asymptote is also going to be what my h is. So that's an important lesson. Whatever your vertical asymptote is also your h. All right, then it's followed by a vertical stretch by a factor of 8. So we have an h of 3, a vertical stretch by a factor of 8. That just means that my A is 8, because remember, stretch, compress, those are all A words. And so we can just write our equation here. We're just going to go G of x equals my A, which is 8, times log base 2 of x minus my h, which is 3. Okay? All right, let's do 2 more of these on the second page here. So 2 more, we have a, number 6, we have a natural log of x for this one. We have a vertical asymptote at x equals -1. Well, we know that that's what my h is. We're going to have an h at -1, followed by a vertical shift up 5. So I want you to pay real close attention. Vertical shift. Shift means that we're moving my whole graph. If it said a vertical stretch, then it'd be my A. But shift means that we are going to shift it up 5, so that's going to be my K. So we have my K is 5, a vertical reflection. So that means that we're going to have a negative A. So we can write this out here. We can go G of x equals negative natural log of x plus 1 plus 5. Love it. All right, last one of this type, number 7, f of x equals log of x. That's our starting point. Given h equals 3, k equals -5, a equals 1/2. Too easy. We're just going to plug those in. So g of x equals 1/2 times log of x minus 3 minus 5. There we go. X minus 3 minus 5. All right. So that's all there is to it, to writing out these transformations for these. Okay. But now let's turn the script and let's start talking about x and y intercepts. So To find an x or y-intercept, what we do is make the other one equal to 0 in my equation and solve. So like here on number 8, if I wanted to find the y-intercept, I would make x 0. So let's go ahead and do that. So I'm going to make x here 0. 0 minus 3 is, of course, negative 3. The one I'm looking for, y, is already solved for, so this one's pretty easy, except, wait a second. Remember what I've been saying, you cannot take the log of a negative or 0, right? If I tried to plug this into my calculator, it'd give me a big error message because we cannot take the log of a negative, okay? So I'm going to write that out over here. We can't take the log or natural log of a negative or 0. Okay, so that's important. Can't take the log or natural log of negative or 0. So this one is y equals undefined. If I plug this into my calculator, I get an undefined pop-up. And so that means that I do not have a y-intercept on this one. So that's what we do for our y-intercept. To get our y-intercept, we plug in 0 for x. What about to get my x-intercept? Well, the opposite. We're going to plug in 0 for y. So we can go 0 equals log base 2 of x minus 3 plus 2. And we can now solve for that x. I can minus 2 to both sides, and we can go negative 2 equals log base 2 of x minus 3. And then, now that I've got my logarithm by itself, how do we solve this? Well, we need to rewrite it in exponential form. So to rewrite in exponential form, we're going to go 2 to the negative 2 equals x minus 3. So 2 to the negative 2 equals x minus 3. 2 to the negative 2, if you plug that into your calculator, you get 0.25 equals x minus 3. Now we can just add 3 to both sides, and we would get 3.25 equals x. So my x-intercept is at 3.25 comma 0. All right, easy as pie. Let's take a look at number 9 now. Same idea. We're going to start by finding the y-intercept first. So to find the y-intercept, we're going to make that x in there 0. So we're going to go we're going to go y equals negative 2 times the log of 0 plus 1 minus 3. Of course, 0 plus 1 is 1. So now that I have all of this, this is just log base 10. So to plug this into my calculator, I don't really have to rewrite this in change of base form. We can just plug it in. So the only thing that I need to do here is just grab my calculator and go and plug this in. So we're going to go negative 2 times log of 1, negative 2 times log of 1 minus 3. So negative 2 times log of 1, hit enter, and we get negative 3. So just like that, we got y equals negative 3. And so that means that my y-intercept down here is going to be at 0, negative 3. So there we go. We have a y-intercept at 0, negative 3. All right, what about my x-intercept? Now remember, to find our x-intercept, we're going to replace our y with 0, or in this case, my f of x. Remember, f of x and y are the same thing, so we're going to replace that with 0. We're going to go 0 equals negative 2 times log of x plus 1 minus 3. Then I'm going to add 3 to both sides. Right, get that logarithm by itself. So we're going to have 3 equals negative 2 times log of x plus 1. Divide both sides by negative 2. Cancel that guy out. Cancel. And we're going to get negative 3 over 2 equals log of x plus 1. So I need to rewrite this as an exponent. To be able to rewrite this as an exponent, we need to remember that this log actually does have a base. There's not a base written here, but this standard logarithm does have a base, and that base is 10. It's log base 10 of x plus 1. So what we can do is we can rewrite this using base 10. So I can go 10 to the power of negative 3 over 2 equals x plus 1. Let me write that out. 10 to the power of negative 3 over 2 equals x plus 1. And last step, let's minus 1 to both sides. And we're going to get x equals 10 to the negative 3 over 2 minus 1. And we can plug that into my calculator to get what x equals. So let's grab our calculator, and we're going to go 10 to the negative 3 over 2. So 10 to the negative 3 over 2 minus 1. Hit enter, and we get negative 0.968. Negative 0.968 is what x equals. Negative 0.968. So that's going to be my x-intercept. So my x-intercept is going to be negative 0.968, comma, 0. Okay? So that's how we find our x and y intercept for these kinds of problems. All right, let's move on down here. Let's take a look at number 10. So number 10, you can see that's using a natural log. So let's start off. Let's find our y-intercept first because that's the easiest. So to find my y-intercept, we're going to replace that x with 0. So we're going to have y equals 1/2 times the natural log of 0 plus 2 plus 5. And once again, we can just plug that into our calculator. I know that 0 plus 2 is 2. So I'm going to plug this into my calculator as 1/2, 1 divided by 2, times the natural log of 2 plus 5. Okay, hit enter, and we get an answer of 5.3465. Now, we're going to round this up. We're going to go 5.347 to round that up. So it's going to be 5.347 here. So that's what my y equals, 5.347. So that's my y-intercept, 0 and 5.347. All right. So there you go. There is our y-intercept. Now to find our x-intercept, we make y 0. So we're going to go 0 equals 1/2 times the natural log of x plus 2 plus 5. So we're going to do this in 2 steps. First step, we're going to get rid of this 5 by minusing 5 to both sides. And we're going to get negative 5 equals 1/2 times the natural log of x plus 2. Then we're going to get rid of that 1/2. To get rid of that 1/2, I need to multiply by 2. Okay? So we're going to also multiply this side by 2. So multiplying by 2, cancel those two 2's out, and we're going to get negative 10 equals the natural log of x plus 2. Now, natural log, just like regular log, has a hidden base, and that base is e. So this is natural log base e. And so for me to rewrite this, we're going to go e to the negative 10 equals x plus 2. E to the negative 10 equals x plus 2. And so what I'm going to do again is we're going to minus 2 to both sides, and we're going to get x equals e to the negative 10 minus 2. And we can plug that into my calculator. All right, so we're going to pull up my calculator. I'm going to go second e to the negative 10, not plus, minus 2. Hit enter, and we're going to get negative 1.9999999, so on and so forth. So as you can see here, if I were to round to this third decimal place, that would make a 10, and we would have to keep carrying that 1. So this is actually so close to negative 2 that we're just going to round it up to negative 2. And we're going to get x equals negative 2. So my x-intercept is going to be at negative 2, 0. Okay? All right, our last one here, number 11. So first step, let's make our let's find our y-intercept. So to find our y-intercept, remember we make x be 0. So we're going to have log of 2, log base 2 of 2. We can rewrite this in that change of base formula. We can go y equals log of my value 2 over log of my base, which also happens to be 2. We can plug that into my calculator. I can go log of 2 divided by log of 2, and we get 1. Hey, anything divided by itself is 1, even logarithm. So we get y equals 1. And so that just goes to show you what our y-intercept is. My y-intercept is just going to be at 0, 1. Okay? All right, what about my x-intercept? So let's go back up here. Let's find my x-intercept. So to do that, we need to make my y 0. So we're going to go 0 equals log base 2 of, not 0, x plus 2. So x plus 2. All right, then we're going to rewrite this. We already have my base, so I'm going to go base 2 to the power of 0 equals x plus 2. So we're going to have 2 to the power of 0 equals x plus 2. 2 to the power of 0. Anything to the power of 0 is 1. You can plug that into your calculator too. 2 to the power of 0 is 1. So we get 1 equals x plus 2. Then we're just going to minus 2 to both sides, and we're going to get x equals negative 1. So just like that. Bing, bang, boom. X equals negative 1. That's my x-intercept, negative 1 and 0. All right, so we're not actually putting grabs on the paper today. The only thing that we are doing is making sure that we know how to find my x and y intercepts, and that we know how to list out our transformations and write our equations for that. Okay. So take a look at your homework. It's on Go Formative. Let me know if you have any questions. All right. Thanks, guys.